Do I need to explain, or can I just
Yeah, just you can do, but yeah, just briefly say, just this was the first step and second step in general. You don't really need to just explain everything in detail. Just yeah,
it's
show
just
show.
for your own use, right? Or you will show this to your students?
And possibly I will share it with my students because just I will use it. Just I'll try to do my own, but just in case my tutorial is not sufficient, maybe I can share what you have done to the students, because I give them some freedom of designing their own board. So I'm not going to show directly your solutions to the students, but if they are struggling, maybe I can share it with them.
Okay. That's okay. That's okay. So I know, like, how detailed I need to be.
Okay.
Yes. Yes. So whenever you're ready, I can start.
Yeah, I'm ready. Please.
Ready. Okay.
Yeah.
So first, I will look for the Arduino Mega to know the size, and so something like this. It's 101.6 by 53.3. So you drag this here, and then 101 by 54, something like this. So this will be the Arduino Mega we can use as reference for the boat. And for the boat, the bottom of the boat, we can use this half cylinder. We rotate it this way. And normally you will calculate how big you will need it for the buoyancy, but I think it should be okay. So if you go to top view, you can, and then it's preferable to change this to the to change the perspective so you see it more clearly, the lines. So something like this would be okay. And we also need space for the engine, so maybe make it slightly longer. And for the front, we will use this half sphere. Maybe rotate it like this. Something like this. Something like this. And then to remove, if you want to remove the top part, for me, I will remove it. You can use this subtraction cube and you place it on top here. And then you select both objects and you merge it with this button here, group. Then you will get this, and then you can merge these two to get one solid for the bottom. So now this is just one solid. And then for the side walls, what I did was I used a cube. Make it the same size as the boat, like this. And then the wall, the height, you can vary however much you want. If we want very low, like 1 centimeter height, we do it like this, and then we duplicate. We duplicate copy and paste. And then say we want 1 millimeter wall. We just reduce this by 1 millimeter here. And then we can do like something like this. And then again, we select both shapes. First, we need to, wait, give me 1 second. The inside, we need to make it a hole. So here we can change from solid to hole. We make it a hole. And then we merge both. We select both and we merge it. So now we have the wall for the front part. And then for the back part, if I remember correctly, I used again the half cylinder and I rotated it like this. Then I make it the same size. Something like this. Again, 10 centimeter. And then duplicate. Make it 1 millimeter less on all sides. Make it whole. Align. Something like this. And then group. So now you have like the overall shape of the boat. And then to have the, for the propeller, you can use a cylinder and rotate the cylinder, make it, first I would recommend you make it the appropriate size. So let's say if your shaft will be 2 millimeters, then you will need a 2 millimeter diameter like this. Then you can make the outside also something like this, and then you group it. So now you have the shaft sleeve. Then you just move it. You rotate it something like this. Just make sure the circle is not blocked by the shaft. So either raise it a little bit. So here, this is good. This both sides are okay, and it's not going through on any side. And then simply, again, copy and paste it, and just look at it like this. And if you want to measure more accurately the position of all this, you can place a ruler from the top right here. You can drag a ruler. So you can place a ruler on this corner. And this will give you the distance. So let's say you want it 10 millimeter from the edge. So this will be 10 millimeter here. And then you can move the ruler to here. And again, here you can put it 10 again. Then so here it was not the same distance. Here the 10, where is it? This 10 distance is not the same as this distance here. It's because it's taking the center point. So we can change this to, by pressing these 3 bars here, it will change the measurement to the side. So then this will be, should be the same now. Now it's symmetrical. So this is basic version of how to, and then you can remove this also. This is just a reference, so we don't need it. If you plan to print this, after you're done, you group everything. So everything should be just one piece. And after this is one piece, then you can save it. You can export it as STL. STL is the format that normally the 3D printer will use to make the polygon and everything. So this is basic version of how we can use Tinkercad to make a very simple hull.
Okay, just one quick question. Now is the deck, it seems is quite thick, isn't it? So that if we use the 3D printer, probably it's better to reduce the thicknesses.
For the 3D printer, so right now, I understand the question. So you're saying the hull is completely filled with plastic, so it will be a lot of waste, right? So in the 3D printer setting, you can state how much you want it to be filled. So normally you will not tell the printer to fill it completely with material. It will have some kind of grid support inside, and you can state how many percentage of the filling you want.
Okay.
So normally you can choose like 5% or 10%. So only 10% will be filled with material, and otherwise it will just like be support material inside. But if you want to make it empty also, we can also do that. You can choose like the solid material like this, and again you align it, you make it the same size, you bring it up. Something like this, and then when you merge it, you will have it empty on the inside. Of course, you do it before you put the propeller,
that's
because
right.
you remove it. But yeah, the order is very important of what you do. And this is very rough. Normally, you will also measure properly, like the distance. But this is a very rough example of how you can.
Could you show me it as well? You also made the place for the Arduino board as well, is with some the degree of the angle.
Oh yes. So basically, right now, when we did this, we only considered if we would put the Arduino board completely flat like this in the boat, but this may take a lot of space, right? So one way to decrease the amount of space that it will use is we can incline it slightly like this or this way also. And it will take slightly less space. Yeah, then you can have more space for your other components, especially like the motor will come underneath here. So maybe it will be better to like incline it this way, it's slightly more forward like this. Something like this. That's why I put it inclined. And for the motor, if you will use the motor drive, you will also need the motor drive. So that's why in my example, there was 2 boards. So you can try to fit it under here, or you can make the boat bigger. Yeah.
So
depends on design choice.
Yeah, if we placed the motor as well, the motor supposed to be placed with some angles as well, right? The shaft supposed to be has some angles.
Yes.
Yeah.
So the angle itself, you can, for example, this board, the angle you can see it's written on the screen right now, like 45, 22. Or if you want to fine tune like the smaller angle, you just bring your mouse outside of the circle, and then it will be like by 1 degree. So then that's how you, after you know the angle that you want your your shaft to be, then you just put the cylinder on that angle that you
okay.
Yes.
Okay. Good.
Yeah. And if you want to do supports, it's the same way. Normally, for Arduino, we will use the hex support, something like this. So let me remove this ruler. So it will be something like this. And then if you want the hole for the screw, again, you just bring this hole and then yeah, bring the hole, you make it the right size, and then something like this. Then you merge it, then you will get the hole. But if you want the screw hole, this one is a bit more complicated. You have to go into the basic shapes here, and then you go into featured collection, I think. And then here you can find some things, but this is not the one. I think it's in shape generator.
Like more shapes.
Yeah, here is in shape generator. Then you can find it's right here. This is the isometric thread. And then when you drag it into the scene, then you can change the diameter and the pitch of the screw and how many segments, the rotation.
Oh, interesting.
And then and then you can use this, and then you put it as a whole, and then you can put this inside of the hex to get the reverse. Yeah, so this is how you do this.
It's good.
Yes.
That's very interesting. I think it's all right. So can I stop the sharing?
Yeah. If you have any other questions, please